All right, this coming through. Yeah, it is. All right, time to start the stream. Well, let's make sure we're ready. Bringing up a couple screens here. Get started. All right. Cool. So tonight I'm going to completely wrap up all this stuff I've been looking at related to trying to like do this one LeetCode problem using SIMD, single instruction, multiple data. So yeah, this the problem is just like looping through some strings, but like looking at, for example, the zeroth element of each string and determining if that kind of virtual string is alphabetical order. If it's not, indicate that it should be deleted. So it's a really trivial problem, but I wanted to take the opportunity to see if I could do it using single instruction multiple data, and which is called SIMD. And so spent like the last couple streams learning some things about that. Kind of like learning let's see, this stuff is not used, but like learning, for example, how to use it. And some things I found along the way was like that it's only gonna, so if your string is, for example, like 32 characters long, this register, when you call this instruction, this function, it's going to load the string into a register, but that register can only hold 16 elements of the string. So that means there's some things we have to do to get this to work with SIMD. For example, we'll have to check the length of the strings that we're processing. The problem statement gives us that all strings that are passed into the function, this function here, are going to be the same length. So, but if they're more than 16, we'll have to do some special handling to use these SIMD instructions. The other part of it is that when I was looking through the Intel reference on intrinsics, reading Intel, the Intel intrinsics guide, and I think we're looking at SSC. And then this is the one I found this function, and it's greater than, but the problem statement that we have, alphabetical order can mean greater than or equal in the way we're doing it. Like if it's in the problem statement, they give an example, CEE is alphabetical. So with this, do a little shifty. Yeah, anyway, yeah, with this, just doing greater than is not enough. So that's the other thing that I had to figure out. I had to figure out how to do it. So that's what I'm gonna be doing tonight. Figuring out how to close the deal on this LeetCode problem using SIMD. I'm pretty sure it's possible. So now it's just like putting together some things that I've learned over the last couple weeks. So the first thing I want to figure out is how to make this a greater than or equal. And I don't like, there is no intrinsic and function for that. There is, you can toggle, you can filter by compare over here. There are like greater than or equal, but This is for a different kind. This does a different thing. We're packed double precision floating point. We're not doing that. We're working with integers. Uh, the elements of a string are basically, or it can be treated as integers. So that's why like this one in the last couple streams I did, we figured out that this is the method we want for greater than, but how do we do greater than or equal? And the way there is, I kind of looked around at how to do that, and it looks like the way to do it is like combining greater than with a max function. So I need to find that. Gotta go over here and do max. Can't tell from looking at my stream if resolution. Hopefully it is. Stream. Anyway, max. So there's this one. Compare packed unsigned 8-bit integer. That should work because the string values are unsigned. They're not going to be negative. So unsigned should be fine. And yeah. And this does the same thing that the greater than function does. Like it's looking at, even though there's 16 characters. Yeah, well, it's doing the same thing as the greater than function that we were looking up, in that it's looking at the 8-bit integer, which is what we want for now. So so let's think about how that works. If we have a max and we pass in an A and B, if they're equal, it's just going to give us either one back. Yeah, so let's think about how that would work. Right, so what we really want is, we want this right here. I have to look up one thing. I don't remember. I have to look up one thing related to this that I can't remember. It's going to compare it's looking for is A greater than B. Okay. So in our case, let's undo some stuff here so I can remember what I did. And do a couple things to make life easy. Take this signature here, paste it in our code. Out because we're not actually going to use it, but I just want to be able to look at it. So same for the where is the, what is that? I guess that's a compare. I just don't remember seeing it when I toggled the, I was just wondering what category to toggle over here that would have given me the max, but searching works well too. So I want this function signature. Okay. So, and then on this one, it's saying it's looking for is A greater than B. And so that's why here we're passing in B in the A spot, because we want to know is string is B, like in terms of determining alphabetical order, we want to see if the characters in the second string are greater than or equal to these ones. So yeah, what we want to do here, I don't totally have my mind wrapped around what I want to do here. Just gonna king it. So what this function will do is if we pass in right, so it's gonna look for the max, and anywhere that it's the same, it will just stay the same. Hmm. I I wonder if this is actually what I wanted. Because let's say, which it was something we were testing. Let's say that string A, build it. Let's say that string A and string B are exactly identical, right? This max will return A. Well, I mean, it'll return, and then greater than is going to be false. Like all the entries in this result will be false. Now, if I do B in the zeroth the zeroth element of the result of this will be B, and then we're going to say is it greater than, then when we do B compared to, this will basically return B, and it'll be is B greater than B, and that will be false. That isn't what we want. What we want is to somehow get a true out of here. So is that what we want? How do we get what we want? Maybe the max has to occur at a different time. I don't see how that could. Might have to go Google. Because we need a result here. We need a result here where when things in these strings are equal, get a result that's true. So I think if we do the greater than on the outside, this is going to give us the wrong. Yeah, I wasn't expecting to like get slammed on this, right? Let's see. Gonna take a think break. Okay. Not really gonna take a break. Just gonna sit here and be quiet for. Do a little Googling. I would kind of prefer to figure out how to do this on my own instead of Google. But since I already kind of Googled it, might as well. Oh. um, Oh. So it looks like what you do is you do compare equal. Let's think about that. So compare A and B for equality. Okay. So if we do, so then we would want to. So if we did, there we do want that. So all right. So if these are equal, then this will basically return A, and it will be then A will equal A, and it will all be true, which will mean it's alphabetical order. Okay. If B is if for any of these elements, for example, this 0th element here, B is greater than, then what's going to return in this, if I'm strictly comparing this string here and this string, then this function is basically going to return, what looks like B. Then in that 0th element, huh, 0th element will return false. It's not equal, which that's not what we want. Oh, we're not trying to check A is greater than. We're trying to check is B greater than equal A. Okay, so I messed that up. So okay, so in this case, when we compare, so note that I have string A and string B, and the only thing that's different is that this first element is B, so it is greater than A. So here, if I do this function, it's going to return, B in the 0th element. And then when I do compare equal, B will be equal to B, and so that will be true. Yeah. But if, for example, here it's A, it's going to return A, and then B, like in this first element, this function right here will return the A value, which is B. And so then when I compare B to A, basically, it would be false. So I think this is actually what we need, right? So if we can compile this and run it, and we should see the result of, we should actually see trues across the board. Yeah, we should see a whole 16 bytes. Yeah, it should be 16 bytes. All 16 elements should be true. All right, let's compile this. Compile. Is that on stream? Doxing my Discord. I gotta get used to it. Not used to it. Because oh sweet. I didn't have to I didn't have to remember these things. Okay. Did it actually compile? Yeah, that ran. All right. Cool. So I'm pretty excited. I think this should work. I'm pretty excited to see get their full solution implemented and see what the timing looks like. All right. I had to look down at my keyboard. My F5 and stuff. I can't do that from keep changing my keyboard. All right. So there is also one thing I want to recap from last stream. Okay. And if we got lots of we look at the these are our SIMD registers, and if we pretty sure we take forgot what we figured out last week, but I think oh no, these contents are literally the members of the string. Like if we go and look at an ASCII table, we'll be able to convert these to the character. I'm surprised. Why are these all the same? Right? These three things are identical. That doesn't fully seem like what I was expecting, but hey, we'll hold on to our horses just a second. I want you technically. So let's do get our memory addresses here. So here we should be able to take this. This is copy the value and go over here to memory and paste. When you do copy value, it copies more than what you need. I just need this address portion. So yeah, so we go and we look at our memory. We can see our string. So 76. I'm interested in what. Yeah, I totally know. I'm not going to get into the weeds on what's on the registers right now. I've done that in other streams. What I want to do is watch the result here. No. Oh shoot, that's copy value, paste. Did some. So right now, I think there's nothing here. But after we hit step over, we're expecting a bunch of F's, a bunch of one. Huh. but we don't. Oh no, yeah, no, this is right because we changed this a. So yeah, a is not greater than. So this is right. That's what we expected. Ooh. Now, to address the thing that kind of stumped me last, so in last stream, I had this configuration. A and B were the same except for this first letter. And then when I ran it, um, it'd be so cool to just be able to go right click, send to memory window. Like, now I can't even remember what I was doing. Okay. Oh, well, okay, no. I really want to talk about this later. I was like, I can't believe I let that trip me. This is what we had last time. This is where we left off last time. Uh, yeah, back to okay. Okay. So last time I was like, why is it? I, for some reason, so there is one FF, right, which is what we were expecting. This one is greater, and I was like, why is that here? Let's turn this. Why is the FF here and not there? But that's goofy. This is the 0th element, and this is like the corresponding memory location. I don't know why I was expecting it to be down here. I guess because I think of like, you know, this is a bunch of hexadecimal, and so I was thinking of starting it down here. So it should be FF down here, and that this spot down here should correlate to like the 0th element of the string. But of course, that's not how it is. This is this has a memory location, and that location's right there. So got marked to FF. Anyway, just want to read. There's nothing. I was really stumped, but there's really nothing. Okay, with all of that, I think we are ready to actually like code a solution. So what we want to do, I think we are ready to code a solution. Ooh. All right, so first off, what we got to do, and we don't need this. Well, we don't need that. Okay, we do still need the length of the vector. We still do need the length of the strings, which they're all the same length. So this is okay. And then we need to like loop count, which would be len divided by 16, right? So if length is 32, then this should be uh is this what we want? If length is 32, then this should be 2, which means we have to loop. That means our strings are so long that we have to loop through twice to process them. But let's say that they're 24. Yeah, we would still want to do 2 loops. So this division right here isn't quite what we want. I need like a ceiling. You know what I mean? Like I wanna divide by 2 and then max, then ceiling. Let's see. Let me look up. I don't actually know how to. I don't know what function. Ceil. Gotta do. Gotta include math, and I gotta do ceil. Does it return an integer? It returns a double. Not. I want it. There's ways to do this. I could do something goofy, like int loop count mod equals like wing mod 16, and if mod not equal to 0, then loop count plus plus. So it's like if length is 24, loop count is going to give us 1, but this will give us 68. This will give us 8, so that means really we need loop count to not be 1. So I'll just do that. Okay, this is the other aspect of the algorithm that we haven't figured out, is like how to count up. Because we have a way here to get you know get what we want in a register, but how do we extract how do we basically like take those 16? How do we take all the contents of this and add it up into like a float or an integer? I guess let's deal with that in a second. I want to get the core of the algorithm. Let's leave this here. We don't need this. So what we want to do is like for right for our loop count. There's some things we have to do here. This may not be as easy as I'm thinking. Like at 0, we want to basically do this right here. At 0, we basically want to do that doesn't work. Right? That doesn't. I'm leaving it there. It doesn't work. Yeah, this is completely wrong. This is not what we want. So, why don't we? So this is the length of the. Oh, right. Right now, this is just looking at how many overall loops we have to do, but we do have to. This the part I haven't thought about at all, so I'm going to slow down a little bit. But we have to make sure that we process every there's a couple. We have to make sure that we process every string in the vector, and then we also have to make sure that we process all the characters in each. Right. So, and then because we have this thing of the restriction, so I think this loop count thing is going to replace basically uh, this loop. Because now we don't have to do for every character anymore. We just have to do, for each chunk of the string. Okay. So, yeah. So if we do, so the outer loop make process all characters. And then there's some inner loop. We're just going to put this in as a placeholder right now. Okay. Okay. So we got to make sure that we do all. And so how do we replace this? I haven't thought about at all about how to replace this inner loop. But we're only looking at one virtual string. Huh. So completely lost my spent so much time figuring out how this stuff works. I haven't really thought about how for loop count. What do we want to do here? This is like for this went over the entire length of our virtual string. Okay, and so here we're looking at okay, so here right. So here you're looking at, for example, the first string and the 0th string, looking at their first or like, their first character. Okay. Shifting my mindset from one thing to the other is like proving to be surprisingly. I think I should have brainstormed this a little more. Okay. So maybe I should break out the whiteboard. So what I want to do here is I want to be like, I had to break out of like thinking about the other algorithm. So what we want to do, this is going to be easier than I think. So let's say three strings come in. What do I need to do? Three strings come in. I need to look at the 0th element of all three. Okay, that's kind of where, yeah, of all three. All right. So what's kind of throwing me off here is that in order to do things this way, we've kind of been looking at, um, you know, processing just two strings. So let's say three, this may not be what we want. So let's say three, it might be easier to just like delete all this. So like, let's just do, sometimes like having your old code sitting there like blocks your brain from thinking about thinking about it differently. So this. So all right. So think about three strings come in. How are we going to process it? First, we're going to process the first two. So 1 and 0, and then 2 and 1. That makes sense? We did, yeah, so we would compare we would be looking at is B, we would look at B and A and then C and B. So we would need to do 2 loops for 3 strings. So if 3 strings come in, so how would we figure out that we needed to do 2 loops? Like in uh, let's say that would be, that's the virtual loop equal to that would be equal to the number of strings that comes in divided by 2, right? So if it's 2 strings, that is going to be 1. So if uh, if it's great, oh wait, yeah, if it's greater than 0, then we want to do virtual loop plus 1 increment. All right, so that gets us our loop, like so that we process every string. Okay. But then the other dimension to this problem, what if we have 3 strings and this is 32 length? Then in order to compare 1 and 0, we have to loop twice. So that's our inner loop. That's our inner loop. Or is it our outer loop? That's our other counter. Call that character. And that's this. I'm gonna divide that by 16. If it's less than 16, happens then? Then it's 0. Really, we only have to do it once. And then if we do if it's greater than 0, then we want to do car count plus plus, right? Yeah, I think that's right. Okay. So in the first loop, we're going to be looking at the first 2 strings, right? So do we need to have car count on the outside? Yes. Hmm. Actually, I guess it's a question. I guess that's I think we could do that differently. Do we want to like if we put right? If we put a loop over the char count, if we put that on the outside, then we would process all strings first. I don't think we want to do that. I think we want to finish comparing the first. Yeah. Yeah. I think on the outer loop we want to do our virtual length. Oh wait, no, I don't think that works. Because if we do the virtual length on the outside, if we do virtual length on the outside, then we would loop over. Let's see. Well, we can keep it the same as our first algorithm. So we like for int I is equal to 0. This is gonna be our outer loop. If we say we want to do all the characters, then we want to do I less than car count, right? I exactly really have no idea how this is int j is we might want to do j is equal less than virtual loop. Um, what are we gonna do here? So what we want to do on the virtual loop, I really think this is take this up. Here we're saying we want to loop over. We want to make sure that we loop over all the character. Well, no, we're saying we want to make sure we loop over all the strings before we move to the next character. So here, if we do this, we want to make sure we go over every. We want to make sure we've considered every string before we move to the next character. Yeah. So okay, I think that still makes sense. But the thing that's slightly different here is now we're kind of like looking at 2 string. Well, no. We're looking at 2 strings at a time here. So let's get this stuff ready for this stuff again. So we want to start off by saying we want to load. I just feel like I don't think this is it. Maybe. I'm kind of like, why do we have to still have a double loop? I guess we still have guess the nature of the algorithm is we still have to have a double loop, but now we're like instead of processing one thing at a time, processing, you know, 16 elements of a string. And another thing I haven't thought about is like, if a string is not evenly divisible by 16, then that means there's going to be garbage elements in the register. And what happens in that? Oh, shoot. They're all going to be zeros. And then that's going to return as true. I just thought ahead by a lot and am now realizing that maybe there's a problem. Maybe there's a problem. Yeah, well, let's get there. Solve it. So here we want to load, be like, so this will be 70A. So A is the previous string. B is the current. Okay. And then we want this result. Spacing out, thinking about a possible different solution. But I think the first thing to do is get it implemented like this. Just to sort of like understand how to do it. And then if it works, we can go back, think about other ways to. So it's going to push ahead. It's going to keep forging ahead with this. Going to keep forging. Uh-oh. Looks like at some point in the chat, I got Doge. Bam. And then there's the whole thing of like, what do we do with this result? Should have probably looked at this too a little closer before trying to implement a solution here. It's like, what does this result look like? Do we do it like, do I start this out up here like this? Can you even do that? How do you even initialize one of these? You have to look at that. How do you initialize? Put a question. Okay, and there's another question we have is like, yeah, well, not gonna happen. All right, so let's just say plus equals. Okay, so you can't do that. So we gotta go look at how to add. You probably have to do a load. Yeah, you probably have to do a load. Let's look at arithmetic. Don't want that, right? What do we want? We don't want to look at the whole thing as like one big integer. Hmm. There's some problems here because like when we, for example, when we were looking at this in the memory, this was like 00FF, FF. That's not one. We just want to, we, that's not one. We just want to add it up as though we want to add up all the FFs as though they were one. Don't come to my stream and chat about Doge. Oops. So we gotta look at how to do add addition. 32-bit integers, we don't want that. I think, what do we want to do? Oh, these are earlier we were looking for max and it's a compare, but it's under the special max. Maybe what we want to do is do like a shift, right? I don't see any of these that work on 8-bit. I have two questions in my head that are like a little bit derailed from like what we were just working. But go and we step through here. Nope. This, I think I can drop the verbose off there, right? Like the verbose is kind of just drop it. So if we go down, what I'm currently thinking about is like two things. One is we'll look at in a second is like what if these strings are less than 16 characters? Other is when we go and we look at this result here, like that answer is hmm, oh. Yeah, that answer is 255. Okay. So we might be able to do something based on that, like divide everything by 255, right? And if it's 250, okay, yeah, we can divide everything by 255. Get 1. All right, so that is one thing. The other thing is how do we convert this down to integer result, like a single integer? And the last thing is what do we do like if this is ABC like this, right? All that. Uh, oh, okay. So that didn't even work. Uh, where's my? Ah. So if it's less than 16, I think this can't even load it. Well, that's a problem. We might have to do a thing where, like, we toggle between being able to use SIMD and being able to use just do the linear solution. This is getting complicated. I wish there was a way to, like, say I want to load it and oh yeah, because we can't tell it the length of the string or anything, right? Yeah, I should have thought about that. We're not telling it the length of the string or anything. So, um, yeah, we have to add some handling around. That answers that question. If it's less than 16, if it's than 16 or it's not evenly divisible by 16, there's like some things that we have to handle, which we kind of expected from like this one algorithm I looked at very beginning. So first off, we can do something like be like, oops, sim- simple. uh, we don't need this stuff. And so then here we can comment all this out. If there's 0 less than 16, then we don't. That's what we want to do. And then we can go down here and do this. All right. I'm gonna take like 5 to 10 minute break. Yep. Smokes if you got them. All right. So where were we? We got to do a couple things. First, I want to figure out, before we go further, I want to figure out how to handle, which we don't, this right now. I want to figure out how to combine, like take result and convert it to just an integer. Because our result needs to be an integer. Let's figure out how to do that. Let's see. Past, store. What does store do? Seems like store is pretty similar to load, right? Pretty similar. Logic. Mask. Miscellaneous. What do we want? Maybe we want bit manipulation? Nah. Arithmetic. Might be a way that we like add 8-bit integers in A and B and store the result. No, that's not what that's like a parallel add, so to speak. Hmm. Oh, interesting. So this is a union, right? But that's not really what we want because then we're having to add a silly thing of like going looping over and adding it all together. I don't. We want like a combine all results into one element. Whistle? I don't think we want to. What is like SIMD add? That doesn't make. No, this isn't. Maybe it did. Yeah, I think this. You have to do something like this where you. What is this? CVTSI. The reason I'm picking the reason I'm picking SSE2 here is like I think SSE2 is pretty common. I went and did SSE 4.2. You have no idea, like, if the computers that LeetCode is running on, they're gonna have that. So may not even have SSE 2. I don't. I'm taking a call there. Oh wait, no, this right here. Oh, let's see. I was like, ooh, this looks like we want convert. That's not. I don't think what I want at all. Convert. Oh, these are convert. Is- Hmm. Yeah, this is the problem with looking at Stack Overflow. You look at it, you don't know what you're doing, and so other people's solutions, I think, just get confusing. It really, really. Think like what this would do is like, yeah, like I don't have A and B. I just have result, right? And I just have result, and I want to add up all the 8-bit elements of result. Uh, I took it and I split it. And yeah, it's weird. Like it's like, oh, let's do this and go really fast. Then it's like, well, just doing something like combining it all into int hard. Hmm. But we know that there's 128 bits. Made this calculation. 128 divided by 8 bits. So we know there's 16. So it just add up. It just like have a thing that it's like they're like an accumulate. Like, super hacky thing to do would be like, yeah, so it's like, would be to add all those elements up. That's the hack. That's like hacky out of our mind, right? Hmm. I'm really stumped on this. This is where like my ability to think about these things very, very limited. Like if we did we say we added result to result. That isn't what we really want to take every element. This is really what we want. Could be I, like you or I, doesn't. This is what we want. Basically that with all 16 elements. So it's like, but is there like, seems like there should be a SIMD way to do that, right? SIMD add all together. Ah, prefix sum, also known as a cumulative. What is this? Is a sequence of numbers generated from blah 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 blah. We wanted this. Hmm, it's much. Let's see what we get here. This. Okay, so you kind of do have to do a lot of wonky stuff. Yeah, I don't think it's worth like, yeah, performance wise, it's not worth it. So it's like int, you can do int sum is equal to 0 and for I less than 16. I, and we're just gonna do sum plus equals result and gonna do that. All right. The other thing we have to figure. Oh, so we want to Basically do this and end up with the answer. Come up with the answer that we want to delete this, that we want to delete. So we hit, before we can do this sum, we also have to do the thing of divide. We need to go look up a divide. Let's see what we get. Arithmetic divide. I'm gonna subtract. Wait, not sub. I guess we can do a mole. So weird. Right? Oh well, division I guess is like a weird operation. So maybe they don't sub. What are we trying to do again? We're trying to turn 255 into 0. Got lots of mole. We don't have. Well, if we add 1, they would all. So I'm not seeing anything. Like divide isn't going to work because this is looking at doubles and stuff. But if the answer, if it is a 255, then I think like what you can do is add. Do like minus 250. We did this, did sub 50. And that sucks. Let's try it. So this one's going to subtract B from A. So we want result to be an A. We want 254 to be in this. Which to do that, I'm thinking we have load. Well, boomer. How do we get a single value? And this is harder than I. This is way, and it's not even like algorithm stuff. It's like working with like what I was hoping was to be able to say like, here's a value, put it in. Could do something. Oh, well, since we're doing all this processing here, we could do say we want to do plus is equal to the result, but that's that's the way to do that. Mm, yeah. It was a was this telling the member reference base type vector of two long, not a structure or union. Doesn't. Well, this is getting kind of boring. It may be time to play some Fortnite. Thought I was gonna finish this tonight. Did not. There seems like there's always more things. Yeah, I think it's about time to play some. Hmm. Guess we could do something like that. Problem is, I think if we do something like this, it's a 16-bit integer, but like for us, then we have to do some bit like if it's 1 1, then I think we had to do some. This is turning out harder than I thought. I'm sure it's just because like I'm familiar with doing it. I guess we could do store. I'm just thinking based on this, like we could extract the low 64 bits to an integer. Could do that, right? But we would have to do some separate processing. I think we would this wouldn't be the desired outcome. I think like trying to extract the result as an array is what we want. Then we have to make an application. Hmm. I don't want to do that. This isn't what. Blah blah blah. I'm not doing all that. I don't even think that's what I want. I don't think. Yeah, I think I want something like this. I think I want this, which kind of is lame. It's kind of a bummer. Like, yeah, so we can allocate our own little thing, which there's ways to allocate 16 byte. This guy has the general idea. The I mean, not really what I want. Oh yeah, 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 yeah. Blah, blah, blah. I was getting so we want a pointer, right? What do we want to call this? Data. What do we have to include to get aligned alloc here? Standard lib. Um, Blind alloc. What do we got? We want our alignment. Okay, so 16, yeah. And then size. We want six. We want 16 of these bad boys. So why is align alloc? And then we have to use. Then we have to use this thing. Then we want to. Then we want to replace what we're doing here with like super. Replace this. Like that. See if that. Wait. Oh, it returns voids. Uh, yeah, and there's something I'm not understanding. Oh, what is alignment? Uh, I don't think I want to line. Hmm. Fuck. All right, so we want line. What? What do we have to include to get this? Fuck. This is wonky. Is wonky. I just wanted to. Some... I think malloc is like on the heap versus alloc is on stack. So we want e, e aligned. Hello. And we want the size. And we don't want that. We want size of int. And the alignment. 6. Okay. Aligned malloc is undefined. Just did it. Oh. Ooh. Oh yeah. Oh yeah. We're winning all sorts of. We are winning. Huh? You have to use the underscore? You gotta be kidding. All right. Do it. Yay. Now it's gotta go look at it. I'm getting all turned around. Void pointer line map. Uh, expression must be a pointer to a complete object type. And casting data to point in 8e an array and then access element. Do I have to? Yeah, so I had to add parentheses so that it does the cast first, then access. Oh. All right, all that, and our expectation now that if we step through here, we're expecting nothing to crash. Uh, oh, we are expecting sum to equal. Oh, we're expecting it to equal. Whoa! Right? Let's take a look at result. Result is 0, 0. Oh, lost. We don't want this. Oh, never understand that. What is that one? We don't want this one. We want this. Oops. F6. F6 doesn't do anything. F10. Mm. I don't think I was expecting. That was not right. Something is wonky. Something is what? That isn't right. That is it used to not be. Go and we look. Oh no. Oh. So wait, no, this is right. The only thing that doesn't match is this second. Right? Okay. So we would expect we do. I don't know my. Oh, this doesn't give us what. Man, yeah. I think I had to like take a break about this code for a little bit. This doesn't give us what we want at all, right? This doesn't. This doesn't. Like simply adding up all these numbers. Only one that we all all these FFs mean that it was greater than or means it is. Think think what we really want to do is flip this around and do less than, right? Yeah. But even so, we have some. Yeah, because like if let's see what take. Why is that 0? Overflow? Oh, because character. Oh, we calculated. I don't understand what's happening. Why? I obviously have no idea what. Obviously, if we do this, that's not. Hmm. Mm, okay. I have one other change. I haven't. Yeah. Let's. There we go. So it was a matter of making it unsigned. It was when I was casting it to sign. That meant it was negative numbers. It's messing it up. Okay, but this still doesn't fix our problem. Sum is going to be some big number. Oh, yeah. So I think because our result looks the way it does, we need to flip our logic. We only want to add up the ones that are actually less than. That gives us our number. So the greater than doesn't. So I think what we want to do is do min here. Okay, well, we gotta do one other thing. We gotta add the divide by 2. Yeah. Sum is 16. That's not what we were expecting, was it? Something something else. Uh, and then we probably want to switch this to A, right? I'm just winging it at this point. Go ahead and put this down where we actually want it. Sum is 50. Winging it is not paying off. Winging is not paying off. All right. So if we do the minimum here, it's gonna, like, if we look at this first element, if we do the minimum, it's gonna return B, it's gonna return A, and then we're gonna compare it to A, and it's gonna be false. I think maybe. So here it will return A. Right? And then we want to say, is it greater than or equal to B? At this, in the second spot, this function will return A, and we'll say, is A equal to B? That will be false. So that one will give us 0. All right, which is cool. But the way that our algorithm is working is we would actually rather that to be 1. Right? So we don't want what we don't want. So if we're asking, is it greater than or equal? That gives us true for everything where it is true. But what we actually want to say is B ever less than A? That's what we really want to check, right? So here we just want to say, is this one right here less than that one? Nope. Yeah, no, it is less than. So we want to put a 1 there. Yeah, is there a less than? Oh, helps figure that out. Less. No, I mean, we should be able to just make our own, right? Here, less. Right here. This is all we need. Uh, compare the integers in A and B for less than. So it says, is A less than B? So what we want is that, don't want that anymore. Not that, not good. Up in the chat. Hello, thanks for stopping by. It's a really, really simple LeetCode problem. It's easy, and we already solved it like using just conventional processing. But since it is easy, I was wanting to try to use SIMD because I've watched some presentations about processing string with SIMD, and I've never done that. I've actually done very, very little with SIMD. Uh, so I thought this was like an easy problem was a good opportunity. But I'm struggling with some stuff right now, so figuring it. slowly figuring it out. Oh yeah. I find that yeah, with the Intel reference page, yeah, like sometimes I have a hard time like understanding. I guess like this colon equals syntax is a little different to me, but I mean that's pretty easy to. I don't know. Sometimes with these, I can't quite ever understand what the function actually does. And then the thing that I was struggling with, like right here, like all this stuff right here, is like all I want to do is extract the data out of my, my result, but you have to do all this crud to do that. It's like kind of weird. It's kind of weird. But right now, I'm switching up my algorithm a little bit. I lost my train of thought. Less than. So it's looking for is A less than B. And I think what we want is we want to check is B less than A. Because if B is less than A, if an L if a yeah, if B is less than A, then it's not alphabetical order. We want to return true there so we can add it up. Okay. So now what we should get, I don't think we still want this. Okay. And then we still want to break here. Yeah, and our sum is 1. So there we go. What we wanted. Yeah, we not all the way there. There's still some things to figure out. Like, so if we go over here and we do like this, we should now get we should now get 2. I gotta go recompile. So one thing about like all this typing a change and then compiling, there's actually a program that I want to check out that could help with that. Take a look here in a second, right after these messages. Yeah, results 2. So there we go. Boom. So we're on the right path. Like we're getting close to what it is that we're trying to solve. Yeah, so like I'm keep typing in changes and then recompiling. There's this software I want to check out. I've been looking at it for a while. Can't remember. It it basically adds a just-in-time compiler. So like as you're typing your C++, it tries to compile it, and so you can see, so you don't have to like type in your code and then go compile it. You just type in your component code, and it's almost more like like Python or something. It can just run it right away, and so you can see the result of your code like pretty much as you're going. So it makes some of this iteration a lot faster. I should probably try it. The only thing that's held me back so far is like it'd be cool if it was showing you like like I don't actually know what it's showing me over here, but I would rather be seeing like registers and memory. Try something. I'll take a look. All right. I might call it at this and go do some Fortnite. It's already almost, well, it's already late. And I don't think I'll get around implementing things. Really want. Yeah, we can play Fort. No, we can play. We can play Fortnite. All right, so let's go back up. No, I don't know. I'm wrestling with this. Realistically, it should take only a few more minutes to add this code in. to take a quick break there. All right. I'm just going to give this like 10 more minutes to see it. So we figured out that oh geez, wrong. I don't know why I do my code editing in VS Code and my compiling and debugging in Visual Studio. It makes no sense. It is. We can't do this. That doesn't. All right, so if the string's length is less than 16, then we just go. I don't know if I like this because like what if you have like a million strings and they're all short? Well, yeah, regardless if you have a million, because like here we still have our virtual loop, which is the size. I don't remember why I needed this, but either and so like the SIMD helps with the number of characters itself, not with the number of strings. So even if there is a million strings, SIMD doesn't help. It's more like this helps when if you had a million strings that were a million characters, that's for the SIMD million characters. If you had two strings with a million characters, that's where the SIMD help in this implementation. So let's just keep going. Sometimes I just had to power through it to figure out. So we load our two strings. I don't think we want to load our strings in this. So, and also this is only so like let's say if the string length greater than 16, we have to do this twice, which is what this length this is supposed to help right here. Yeah, that's what this helps with. So this actually needs an additional parameter here where it's like yeah, where we're not just getting the string from the beginning. We want to get the string either from the beginning or like some increment of 16 into it. So I think because of that, I'm gonna stop here because like once you go into your string and then go some number of characters in, now like this C string method isn't gonna work. So we have to like do some shenanigans to deal with the fact that the strings may not be 16. And anyway, so I'm going to call it at this point and come back to it tomorrow. Maybe tomorrow we can find wrap it. All right. For stopping by in the chat. Catch you in tomorrow's stream. Bye.